Hello, this is Christian here. In this video, I'm going to solve some of the problems of your study guide for quiz number 2. I'm not going to do all of them because there are too many, but just like the first video, I'm going to be as comprehensive as possible in all the problems. So in the first problem, I'm doing problem number 1, part D, E, and parts L and Q. So in this problem, you're given two functions. The first one is f of x. The second one is going to be g of x. And they are defined by different rules. So f of x is just a quadratic polynomial and g of x is a line. So part D is asking you to take g of x, which is essentially the output of the function g when the input is x, and then you have to add 4 to that output, okay? So if my input is x, then my g of x is just going to be 4x minus 3. That is precisely how g of x is defined. And then to this output, I'm going to add 4, okay? And then I just have to simplify a little bit more because we have two numbers here that we can simplify, and this becomes 4x plus 1. Okay, and this is our solution. Now in the second problem is a little bit different because now the 4 is not being added. This 4 is not being added to the output. It is being added to the input g of g. Okay, so the way I like to think about this problem is imagine that your input is going to be an empty box. So I'm just going to do this in a different color. Let's just say that g is going to take something in that empty box or mystery box, and based on the definition of g, which is right on top over here, I'm going to multiply whatever I have on this box by 4, and then I'm going to subtract 3. Okay, so this is what the function g is doing. All right. Now, in this case, what's inside the box is just x plus 4. So I'm just going to write x plus 4 here and x plus 4 here. And this is actually what we have to write on top. So this is equal to 4 times x plus 4 minus 3. Okay? Then we can simplify that a little bit more because we can distribute this 4 here and over here. So this actually becomes 4x plus 16 minus 3. And this is the same as 4x plus 13. And this is our solution. Okay, so whenever you see a weird input, like in this case, x plus 4, think about it in terms of an empty box that you can put whatever you want, and that is actually my x. And once you figure out what you have to put on that empty box, the rest is just simplification. All right, so let's move to problem L. So again, I'm just going to do it step by step. I'm just going to do this term over here alone. So this is going to be the blue region, f of x plus h. So remember, we think of f as having an empty box for the input. Let me do it in purple, perhaps. So this is f of something. And the way that this function is defined is over here. Okay, so this is the definition of x, of f of x. So what I'm going to do is I'm going to take that empty box. Oops, I'm sorry. I'm going to take that empty box, square it, and then multiply by 3. That is essentially this first term over here. Then once I do that, I'm going to take twice as much as there is in the empty box and subtract it, and then add 1 at the end. Now the only difference is that in my box, I have x plus h. That is going to be my input. So I put the same over here and the same over here. Okay, so that is just the blue part of the entire problem. Okay, so let me just put it over here. This is the blue part. Okay, and then for the yellow part, we simply plug in f of x. Okay, so that is what happens when you plug in x to your function f, which is precisely defined here on top. Okay, so let's do that. So the blue part becomes 3 times x plus h squared minus 2 times x plus h plus 1. That is just the blue part. And then I'm going to subtract the entire f of x function, and that is 3x squared minus 2x plus 1. And I'm going to divide all of that by h. And I'm going to get rid of this part over here because I'm going to need more space. Now I'm going to expand this part over here, and I'm going to distribute the 2 in this part over here. So when I do that, this becomes 3 times x squared plus 2xh plus h squared. That is simply expanding this term over here. Then I'm going to distribute the 2 to the x and the h, so this becomes 2x minus 2h, and it has to be minus because remember there is a negative sign over here, plus 1, which is this plus 1 over here. And then when I apply this negative sign to all the terms, this negative sign to all the terms inside the parentheses, all my signs are going to change. So this becomes negative 3x squared plus 2x minus 1. And all of that is going to be divided by h. Now I can distribute this 3 over here, and over here. So this becomes 3x squared plus 6 times xh plus 3h squared minus 2x minus 2h. And I'm just rewriting everything I have on top. Minus 1. All of that divided by h. Okay, and now this will be very simple because if you notice, okay, oops, and I made a mistake over here. This should be a plus over here. So now it should be really simple because notice that I have negative 2x here and positive 2x over here. So this 2 terms will cancel out. I also have a positive 1 and a negative 1 over here. So these terms will cancel out. And I also have a 3x squared here and a negative 3x squared here. So these 2 will cancel out. And the only thing that I'm going to end up with is 6, let me do it in black, 6xh plus 3h squared minus 2h. All of that has to be divided by h. And notice here that I have an h in all the terms over here, so that I can actually factor that out. This becomes 6x plus 3h minus 2 divided by h. I can cancel the h out, and I end up with 6x plus 3h minus 2. And this is going to be my solution. All right. All right, so let's do part Q. So remember that this type of notation, okay, whenever you see this type of notation, that doesn't mean that we're multiplying f by g, okay? What this means, in simple words, is that we're going to input x into our function g, and that is going to give us an output. The output is represented by g of x, and that output of g is going to be then an input for f of x, okay? So again, think of f of x as f of empty box, and maybe will help to clarify things a little bit more. So remember that my function f, I'm going to put something into my function, and what that function is going to do is that it is going to square it, multiply it by 3, then it's going to subtract twice as much as I have in my input, and then it's going to add 1. Okay, and just to make sure, let me double check. Yes, okay. So now the only difference is that the input is g of x. So my input is going to be g of x. Okay. So this actually becomes, let me do it in green maybe. This actually becomes 3 times g of x squared minus 2g of x. And I don't want that. G of x plus 1. Okay. And I'm going to get rid of this because I'm going to need more space. Now I have a formula for g of x. And g of x is given by this expression right here, 4x minus 3. Okay? So I'm going to just rewrite g of x as 4x minus 3. So this is going to be 3 times 4x minus 3 squared, because we have to square it over here, minus 2 times 4x minus 3, and then this plus 1 over here. All right? So now the only thing we have to do is to expand this term, then distribute this 3 in all the terms, and over here distribute this 2 with all the terms. Okay, so let's expand the first parentheses first. So this is going to be 16x squared. Let's do it this, so minus 24x plus 9. And here I'm just doing the FOIL technique. So I'm doing this one squared, and then I'm doing twice as many as this times this, which is 12x. So if you take 12 twice as much as 12x, you're going to get 24x. And then I'm going to distribute the 2. This is going to be 8x plus 6. Remember that we have a negative here and a negative here, so the result has to be positive. And then plus 1. So now I can distribute here and over here and over here. And 3 times 16 is going to be 48 x squared. 3 times 24 is going to be 72 x. And 3 times 9 is going to be 27. And then I have minus 8x plus 6 plus 1. Or let's do plus 7 since we can simplify that a little bit more already. So plus 7. And now I'm going to basically group similar terms. So this is 48x squared. And I can take this term and put them together. And 72x or negative 72x minus 8x is going to give me 80x. And then 27 plus 7 is going to give me, so I'm just doing this plus this. That is going to give me 34. And this is my solution. So all this means is that when you chain g and f together in a composition of function, the resultant function is going to be this polynomial right here. Okay. All right, so now let's jump to a different problem. So this is problem 2, and I'm only going to do three or 4 problems, or 5 it seems like, or maybe a little bit more. No, I'm only going to do 2 problems out of problem 2. Okay, so here we have some different definitions for f of x. So now f of x is defined as this. G of x is just another function. And then h of x is another function that is written in terms of x and f of x. Okay? So let's do the first one, part E. So again, I just like to think of my functions as the input in my functions as empty boxes. Okay? So all I have to do for h is I'm going to put something in my box. Okay? And what h is doing is that it's going to take whatever I put on that box, add 1, and put this as an input for my f divided by the same thing I put on the box. Okay? So now I know what I have on my empty box, which is negative 5. So I just do this. Okay? And this becomes, so f of negative 5 plus 1 is going to be f of negative 4 divided by negative 5. Okay, so let me get rid of this. All right, so now f is defined by this rule. Okay, so again, f, I'm just doing f now. If you think of the input as an empty box, okay, so f is going to take the box, whatever is on the box is going to square it, add 2 to it, and then divide by 3. Okay. So I'm going to do the same thing here. It's just that what's inside the box is negative 4. Okay. So this is actually negative 4 squared plus 2 divided by 3. That is going to be by f of negative 4. And all of that has to be divided by negative 5 because we have a negative 5 here. Okay? So I can simplify that a little bit more. So negative 4 squared is 16, plus 2 is 18, divided by 3 is 6. So I'm actually going to get 6 divided by negative 5. And this is my solution. Okay? All right, so now I have to work with g. So I have g of x squared minus 7. All right, so again, I'm just going to think of whatever I have on my input as something to put in an empty box. Okay, so what does that mean? Well, if I think of it that way, right, g is simply taking whatever I have of my empty box, and I'm going to follow this rule over here. It's going to take whatever I have on my empty box, and it's going to subtract 2 to that, and then take the square root of that result. Okay. Now it just so happens that what's inside my box is x squared minus 7, x squared minus 7. Okay, so that's what I'm going to write for my g of x squared minus 7. So it's going to be the square root of x squared minus 7 minus 2. Okay, and this can be simplified a little bit more because I have a negative 7 here and a negative 2 over here, so that becomes negative 9. And this is the square root of x squared minus 9. And this is our solution. So it's important to keep in mind that this is not equal to the square root of x squared minus the square root of 9, which will give you x minus 3. Okay, these two things are not equal. Okay, the only way you can separate a radical like that is if you're multiplying over here, but we are subtracting. Okay, so this is the best we can get. Okay, the square root of x squared minus 9. All right, so let's do problem 3, part 5. So in this problem, we basically have to simplify our expression. So we have to find an equivalent expression for g of x by simplifying, and this is very, very close to what we did on the first quiz. So I'm just going to review the same stuff again here. So here we have a fraction. Okay, we have a fraction that is raised, to some exponent, in this case squared. Okay, and I'm going to follow the following law of exponents. So when you have two things in a fraction and you raise that to the power of n, what you simply have to do is apply the exponent to the numerator and the denominator. Okay, so that's what I'm going to do first. So I'm just going to apply the square to the numerator and the denominator. And the denominator is 5 times cubic root of x squared. Okay? Now, I can apply another rule here, because remember that if you have two terms multiplying each other like this, raised to some power, I can simply apply the exponent to each factor. Okay? So all that means is that I'm going to apply this 2 and put it over here and over here as an exponent. Okay? So 2 squared becomes 4. This is just the numerator. And the denominator is going to be 5 squared times the cubic root of x squared. Now here I'm going to apply two rules. So one rule is the fact that the cubic root of x is simply x to the power of 1/3. And I'm also going to apply the fact or the rule that says that if you have something to the power of n and you take that thing and raise it to the power of m, then we have to multiply the exponents. Okay? So we're already done with the number 4 on the numerator. 5 squared is 25. And then here, this becomes x to the power of 1/3 squared. But simply we have to multiply 1/3 times 2. So this becomes 4 divided by 25 times x to the power of 2/3. And that is our solution. Okay, so this is very similar to what you had to do on the first quiz. It's just that now we have functions involved. Okay. All right, so let's move on to problem 3b, part 4. Okay, so here we have a function that we don't know how it is defined necessarily in terms of a formula, in terms of x squared and x cubed and so on, but we do know that f of x, big F of x, is essentially defined as the ratio between f and g, or small f and g. Okay, and we're also given some information here, so we are told that f of x is 0 only when x is equal to negative 2/3, 1, and square root of 13, and that g of x is only 0 when x is negative 3, 0, and 1. Okay, so we have some information here, and now we have to find for what values of x, if any, does the big function f of x is equal to 0. Okay, so what we want, and let me write it maybe like this, so this is going to be the solution. So we want to have f of x, which is equal to f of x divided by g of x, to be equal to 0. Okay? And this only happens when the numerator is equal to 0 and when the denominator is not equal to 0. Okay, because remember, if the denominator is 0, then we will have a 0 in the denominator, and that is undefined. So we cannot divide by 0. So we have to find all the values of x that will make f of x equal to 0 and g of x not equal to 0 at the same time. Okay, and those values, so let me write it in purple. So these values are precisely x equal to negative 2/3, and the reason is because negative 2/3 here will make f of x equal to 0, and it will not make g of x equal to 0. Okay, which is what we want. We want only the numerator to be equal to 0. And the same happens with the square root of 13, because the square root of 13 will make f of x equal to 0, and it will not make g of x equal to 0, which is what we want. Now we cannot select 1, because even though 1 makes f of x equal to 0, 1 also makes g of x equal to 0, and we want to avoid dividing by 0. Okay, so these are the only values for x for which big F of x is equal to 0. Okay. All right, so let's jump to problem 3c, part 1. So here we have to use the conjugate of the numerator in this case to rewrite this expression as something else. The reason we want to do that is because we want to exploit difference of squares. So remember that if you have something like a, let's say minus b, which is precisely what we have over here, something minus something, we want to rewrite this thing oftentimes by multiplying it by a plus b divided by a plus b. So when we do that, we are basically, this whole term in blue is equal to 1 because we're dividing something by itself, and that is just 1. And we're multiplying the expression we have by 1, so we're not really changing anything. But we can change how it is written because we can use difference of squares. And let me use purple here. Because the numerator becomes a squared minus b squared. Okay. And sometimes we can simplify stuff following that rule. So the rule that we follow there is that if you take a minus b, multiply the conjugate a plus b, that is always going to give you a squared minus b squared. And the square here is really beneficial because it would help us get rid of this radical over here and over here, at least for the numerator. So that is what we're going to do. Okay, we're going to multiply. Let me do it in green. we're going to multiply by the conjugate of the numerator. And the conjugate is simply changing the sign here on the second term. So this is square root of x plus 5 plus square root of 5. And we don't want to change the value of that function, so we have to divide by the same quantity. So let me do it like this. X plus 5 plus square root of 5, okay? And now we can do the first term squared, and when I do that over here, all I'm going to get is square root of x plus 5 squared minus the second term, which is this one, squared. So it's going to be square root of 5 squared, and then I'll have to multiply this term by this term, the x that I have in the denominator. So this is going to be x times square root of x plus 5 plus square root of 5, okay? And I have to get rid of this stuff. I need a little bit more space. All right, so when I do this term and this term, all I have to do is get rid of the square roots. So the numerator becomes x plus 5 minus 5 divided by x times square root of x plus 5 plus square root of 5. And I can cancel this 5 and this 5. They're subtracting each other. And this becomes x divided by x times square root of x plus 5 minus, or plus rather, square root of 5. And then I can cancel this x with this x. And this becomes 1 divided by square root of x plus 5 plus square root of 5. Okay, and this is my solution. So what we simply did here is basically we wanted to rewrite f of x in a different way. Okay, so this expression is equivalent to this one on the end. And depending on the context of the problem, sometimes working with this expression is a lot easier than working with this one. Okay. All right, so now let's do problem 3D, part 4. So again, here we have to simplify this expression somehow, or rewrite this expression differently by simplifying the expression that we have. So first of all, notice that I have a c over here and a z over here. So I can actually factor c out on the numerator, and I should have used blue. So if I factor z, I'm just going to get c times z minus 5. Okay, and I can also factor this polynomial as well. So this polynomial can factor as z over here, z over here, and then I have to find two numbers such that when I multiply them together, I get negative 15, and when I add them together, I get negative 2. Those two numbers are negative 5 and positive 3. Right? If you multiply negative 5 times 3, you get a 15. And when you add negative 5 and 3, you get negative 2. Okay? So notice now that I can cancel. I have this is equal to this, so I can cancel this term completely. And all I end up with is my z on top and z plus 3. So notice how this expression got somehow simplified to this expression. And the second one, this one, is a lot easier to work with than this one. Okay? All right, so over here in problem 3E, part 1, now we have two different functions. We have f of x equal to 1 over x and g of x equal to this ugly thing right here, square root of 4x to the 5th power minus x cubed. And we have to find f times g of x, and we have to somehow put this 1 over x inside this radical. Okay, so let me show you how you can do that. So we want to find f of x times g of x, and that is simply 1 divided by x times the square root of 4x to the 5th power minus x cubed. Okay? And we somehow want to put this x inside this radical, but we cannot simply divide whatever is on the radical by x and then call it a bigger radical. We cannot do that. Okay? Let me explain why that is. Okay? So what we want is to rewrite this expression for x so that it has a radical. And if it has a radical, then I can write it inside this expression right here. Okay? So I'm just going to do the following. So x is positive, is greater than 0. That's one assumption that we have to make that I didn't write over here. So I assume x is positive. So what I'm going to do is I'm going to do this expression right here. And notice that the square root of x squared is absolute value of x, but x is positive, so this will give me just x times whatever we have here. And now I can plug in this expression and match it with the expression on the right, okay? And this is simply following the laws of exponents. So now I can write this. Let me just write it maybe more clear. Divided by the square root of x squared. And this is actually a big square root of 4x to the 5th power x cubed divided by x squared. And the reason for that is because of the laws of exponents. Okay, so remember that this radical, all it means is that you're going to take, let's say, a divided by b, since we have a fraction over here. When you take a radical like this, all we're doing is taking this fraction and putting a 1/2 for the exponents. So radicals are just fractional exponents, okay? But by laws of exponents, I have to apply the exponent to the numerator and the denominator, okay? So this becomes, if we want to rewrite the fractional exponent as, again, this becomes square root of a divided by square root of b. So if we want to put this terms, a divided by b, a and b, in one fraction inside of the parentheses, both have to have the same radical so that we can jump from the right to this expression, okay? Which is what we were trying to do over here. So I cannot put this x inside this radical because it needs another radical like this. But in order to put that radical, I need to square it to have an equivalent expression, okay? So that is what we're trying to do here. And now, notice that the numerator over here has a common factor of x, so we can factor it out. So let me just write it below here. So this becomes the square root of, the smallest factor is x cubed, and then 4x squared minus 1 divided by x squared, okay? So the smallest factor of x that I have here is x cubed. Okay, so I can factor it out. And when I take x cubed times this, I'm going to get 4x to the 5th power minus x cubed. Okay. And now I have 3 copies of x over here, 2 copies of x over here. So I have to cancel 2 of them because I'm dividing by 2 of them. So this becomes x times 4x squared minus 1. Okay, and that is my solution. So all of this is my solution. The reason I only have x here, just in case you're wondering, so I follow the laws of exponents that says that if you have x cubed divided by x squared, I have to take 3 minus 2 for the exponent, and this is just x. And this x is precisely the x that I have here. Okay? All right, so now I'm going to solve the last problem. This is problem 4, only part A. And here we have to write an equation of the line that goes through this point over here with a slope of 4/3. Okay, so remember that in order to know the equation of a line, if you want to determine the equation of a line, we either have to know 2 points in the line, because as long as we know 2 points, we know how the line behaves, or you need 1 point, but then you're going to need the slope, because we need to know where the line goes through, and then we need to know how inclined the line is, and that is going to be the slope. Okay, and remember that the slope, so let me just write here the solution. So the slope here is given, okay? But we also have a formula for the slope. If you remember, recall that the slope of any linear function, well, let me just write it this way. So let's say you're given 2 points, on the line. Let's call these points x1, y1, and the other one x2, y2. So given 2 points in the line, the slope is defined as m. Usually we write it as m, y2 minus y1 divided by x2 minus x1. Okay? Now the difference here is that we have 1 point. So you can think of this point as x1, y1. So we have this point over here, and we also have the slope. Okay, so if we have the slope and we have only 1 point, we can then know all the other points y and x. Okay, not just 1 point, we can know all the points. So instead of y2, oops, let me just write it this way. Instead of y2 and x2, I'm just going to write y and x, because I can know any point yx or xy in the line. Okay, so I have the slope. The slope is 4/3. Okay, and that is going to be equal to, based on the formula above, that is going to be equal to y minus my y1, which I have because I have a point already, divided by x minus my x1, which I also have, which is negative 2/3. Okay, and I'm going to multiply by x minus negative 2/3 on both sides. So if I do that, I end up with y square root of 5 equal to 4/3 times x, and I'm just going to switch. Negative times negative is positive, so I'm just going to switch to plus 2/3. Okay, and you can leave your solution like this. So this kind of expression is known as the point slope formula. And the reason it is known this way is because you're given a point and you're given a slope. Okay, and in general, that formula is of the form y minus y1 equals your slope minus x minus times x minus x1. So if you have your slope and you have 1 point, which will be your x1 and your y1, as long as you have that, you can find an expression for your line in terms of y, for your line y in terms of x. Okay, so you can leave your solution like this, or we know that lines have the form y equals mx plus b. Okay, or we can rewrite this expression to have this form. Okay, so just as a review, I guess, let me just do that for you. So I'm going to write this expression in the form of mx plus b. All right, so this is going to be y minus square root of 5. So I'm going to distribute 4/3 here and here. This is going to be 4/3 x plus 4/3 times 2/3. Okay, then I can add on both sides square root of 5, so I'm going to end up with 4/3 x plus, when I solve this part over here, I get 8 divided by 9, and then the plus square root of 5 that I added. Okay, and if you want to combine these two terms in the parentheses in just one term, this will become 4/3 x plus 8 plus 9 square root of 5 divided by 9. Okay, And now this is of the form y equals mx. Your m is 4/3. That was actually given over here. Plus b, plus b. And my b is this fraction over here. Okay, so either one works. All right. So hope that this helps. If you have any questions with any of the other problems, don't hesitate to shoot me an email.